So yeah, weather is the day-to-day, climate's over a long period of time. And the definition that I'm going to give is that weather weather is the conditions of the atmosphere over a short period of time. Conditions of the atmosphere over a short period of time, i.e. the day-to-day, right? Like conditions in the atmosphere over a short period of time, you know, like maybe in parentheses, the day-to-day, right? What was it like today? What's it like tomorrow? Climate is the average weather for a particular place and time period. Climate is the average weather for a particular place and time period. Usually in 30-year chunks, right? 30-year periods. The average weather for a particular place and time period, usually over 30 years. Here's what I want you to do. We're going to do some climate or weather statements. I'm going to tell you a statement. If you think that statement is about weather, you are going to need to walk over to this side of my beautiful line I just created. If you think that statement is about climate, you're going to walk over to this side of that line. All right? So imagine there's a line for me that runs out this way. And the thing I say between me and Mr. Oliver is the thing that I say is about weather, this side, climate on that side. Are you ready? We'll start easy. It hasn't rained today. Weather or climate? It hasn't rained today. Weather or climate? Alright. It's windier here in the wintertime. It's windier here in the wintertime. I definitely saw some people looking around like, alright, he's vlogging. Alright, cool. Yeah, right? So, we're talking about longer periods of time generalization. It's dry in the desert more than other places. It's drier in the desert than in other places. Climate. Last night the river flooded. gonna last until next week. This heat wave we're experiencing is gonna last till next week. Yeah, it's weather. Okay. Alright. Mount Washington, the top of Mount Washington is colder than the valleys below. There was an inversion this morning, and Freiburg was colder than Mount Washington.
Are you just like in the middle? Are you like half and half?
We've had a lot less snow this year than we should.
Oh.
What do you think? We've had a lot less snow this year than we should. What it is? Climate.
And does it matter the age of the person saying these statements?
We've had a lot less snow this year than we usually do.
Wait.
So what do we talk about? We said weather is the day-to-day. Climate is the long-term, over 30 years. So
You're talking about the...
we've had a lot less snow this year. That's tricky. That was a good question.
Oh,
I got, yeah, it was kind of tricky, yeah. So in that case, I was trying to be kind of tricky there. So in that case, I'm talking, even though we're talking about an entire year, and it's not the day-to-day, right? We're talking about it like an entire, calendar year, not the day-to-day. You still couldn't make assumptions about climate based on that, right? Like, this year, we've had about half the amount of snowpack. We've only gotten about, when I last saw, about mid-40s, about 42, 43 inches of snow this year, versus the usual for this area, which is around 85. So, even though it's been a low snow year this year, you wouldn't say, oh, we always get this amount of snow in Freiburg, right? Like, this is what's usual. No. And so, even though it's not necessarily the day-to-day, it's not talking about climate. And that's going to be, this part right here is super important, so I need everyone to pay attention to this one part.
And quiet feet. When you move your feet, you're making noise and we can all hear it. Thank you.
This part's super important, because when we talk about climate change later on, you 100% hear people say still, and see people tweet and things that are like, oh, it's, snowing today in DC, so much for climate change. Or, we've gotten all these storms this year, climate hoax, or something like that. So, it's really important to understand that weather is the day-to-day, but even like a full year's worth of what happens, even like 3 months of intense storms or a big heat wave, don't necessarily mean that changes 30 years of observations and data.
I'd do like 10 years with that.
Yeah, so I mean, if like you had it for 10 years, then you could say, hey, there's a trend, right? Like, maybe that doesn't change all the data and the records, but there's definitely a trend that is occurring. And they would look into that and say, well, okay, why is there this trend, right? Why is this happening? That's good question, good point. All right. So I feel like we should feel great about weather and climate, right? And the part that I want to tease out is that idea that weather is the day-to-day, climate is the long-term, but it's not like that black and white, right? It doesn't just mean like yesterday, today, and tomorrow. It can mean like a year. It can mean like 2 or 3 years, right? But that doesn't necessarily mean climate, which is those big 30-year chunks. And 30 years is a long time in our lives. I mean, you're not even close to it, right? You're not even close to that. A long time in my life, But when we thought about that geologic timeline, it's just like a little, tiny little blip, right? Insignificant blip. Okay, we gotta keep moving. I think I was gonna do this out here, but I think it's too windy, so I think we would maybe need to go back by the building, so we're kind of bunkered in like more of a sheltered space for this next thing. So let's walk back towards the building and find somewhere where we're out of the wind. We gotta be out of the wind. We're gonna be looking at clouds and precipitation, warm and cold fronts, and high and low pressure. Observing and reporting the weather, and mountain weather. Those are kind of the categories we're going to be looking at. Clouds and precipitation, high and low pressure, warm and cold fronts, observing and reporting, and mountain weather. Raise your hand right now if you feel really good. Oh, I can repeat that because I see some people writing that down. Sorry. Clouds and precip, high and low pressure, warm and cold fronts, observing and reporting, and mountain weather. That's how we're going to break down this weather unit. I'm just curious. Raise your hand if you feel like you could really explain well how and why a cloud is formed. You're like, oh, you want me to say it again? Sorry. Clouds and precip, high and low pressure, warm and cold fronts, observing and reporting, mountain weather. So, just out of curiosity, you're like, oh, I can really explain how a cloud is formed. Like, I feel like I know that and I got that down. Okay, 1 or 2 people. What about high and low pressure? Warm and cold fronts, mountain weather. Okay, alright, I'm just curious, just taking a baseline. So, we're going to start today with clouds. That's where we're starting today, with clouds. And, well, hopefully we get up on Jockey Cap, we'll have some. Because right now we don't have any. And we're going to begin this with an experiment. And basically what we're going to do is we're going to build and create a cloud inside this bottle. Have you done this before? Good. So, what I want you to do, 1, 2, 3, 4. Let's get into groups of 4 or 5 people. Let's get into groups of 4 or 5. And you guys want to be a group of 4 right here with Logan? There you go. Alright. So, I'm going to give each group a bottle, and within this bottle, there are going to be 3 ingredients to create a cloud. We're going to go through the process. I'm going to show you how it's done, and then I want you to try and figure out as a group what's happening and why that cloud is formed. So, because some years I'll walk through and explain the whole process, this year I wanted to do some critical thinking and have you try and figure out what's going on. So I'm going to walk around. I'm going to give each group a bottle, and then I'll come around and give you the ingredients to make a cloud. Oh, there we go. All right, where's the cap? Cap. There we go. Okay, what I want you to do now is Oh. You see what's happening? You see what's happening? Cloudy, clear. Cloudy, clear. Cloudy, clear. Cloudy. It's not that exciting. It is that exciting. It's more exciting than you're expecting. I'm sorry. Okay, ready? And we need to have the cap ready, so as soon as I ask for it, we gotta throw it on there.
Doing great. Oh.
Alright, throw the cap in. There we go. Now, here's what I want to show you. Look carefully. You jumped. Oh, clear, cloudy, clear, cloudy, clear, cloudy, clear, cloudy. Do you guys see that?
Yes.
We have a cloud, and the cloud goes away. We have a cloud, and the cloud goes away. So, how did we make our cloud? What were the ingredients we needed to make our cloud? And why does the cloud disappear? That, oh, sorry, what did you notice? All right, water, hot air. What was the last one you said? Pressure. Oh, pressure. Excellent. Carbon dioxide involved? Oh, because from the smoke burning. All right. So we know that what went in that bottle was water, smoke, right? And then we had to squeeze that bottle. So in order to make a cloud, you do need water, and then carbon dioxide is you're on the right track, but smoke is not only gases, but it's dust particles. And what that's going to be called, we're going to give a fancy word for that, and that's cloud condensation nuclei. Cloud condensation nuclei. Condensation, C-O-N, nuclei, N-U-C-L-E-I. Nuclei, like nucleus, right? N-U-C-L-E-I. So we have water. 1. We have dust particles. 2. And those dust particles we're calling cloud condensation nuclei. And then 3, we have a change in pressure. And a change in pressure equals a change in temperature. So, 3 ingredients: water, dust, condensation nuclei, and a change in pressure / temperature. So, let's get to that section. That was the first question. What are those components? Second question is, why does the cloud disappear and reappear? If we're having a change in pressure and temperature, why does that cloud appear and disappear? If you think back to our water year, we talked about how water evaporates, cools, and condenses, and then does what? Precipitates, right? The water cycle. Water evaporates, cools, condenses, and precipitates. So what is happening in that bottle? Why does that bottle appear and disappear? Why does that cloud appear and disappear? What are you changing? What is happening? Who wants to put it together? Yeah. It's not raining. That's a good guess. It's not raining. It's not raining in there. What is happening? You're doing what to that bottle, and what do you think that's affecting the bottle? It's affecting the pressure, which affects the temperature. So if we need that, in order for a cloud to form, it has to cool. When I squeeze it, what am I doing to that bottle? I squeeze that bottle and the cloud disappears. What am I doing to the inside of that bottle? Adding heat, raising the temperature, right? So, when I squeeze that bottle and I apply that pressure, the cloud disappears. When I stop squeezing that bottle, the temperature drops slowly, and those molecules, right, that water, can cool and condense. So normally water's like, there's water all around us right now. Like there's water all around us. Like all around your head and face right now, there's water. Now, when that water gets cold enough and can find some dust particles, it can start to stick together. And when it sticks together on those dust particles, it becomes a cloud. I'm gonna wait for these guys to go because they have to figure this out in like half an hour. Whew, I don't know if we're gonna have time to walk up there. Thanks. Hour and a half is not enough.
No.
It's just like clearly not enough. Okay, so let's walk through this again. 3 ingredients per cloud. Water, and that water's always moving around. That water needs something to stick to. That's the dust, the condensation nuclei. Once it does that, and then there's a change in temperature, it can cool, condense, and form a cloud. So those clouds right over there, what we're looking at is we're looking at water that has attached itself to tiny pieces of dust, gotten cold enough that more of those water molecules start attaching, and a cloud is formed.
Why are some clouds like reddish and some are white?
Oh. Well, it could have something to do with one of those 3 ingredients, right? So that if you change the temperature, if you change the dust particles, if you change the amount of water moisture, that's going to change the way the cloud looks, right? So here's what I want to do to finish off our morning. 20 minutes, we probably shouldn't walk up there. It's going to take too long.
If it was like August, yeah, let's go up. But
it's going to we'll lose 20 minutes just putting those things on and off. Okay, so here's what we're going to do. This is a great lead-in. In your groups, I'm going to hand you a packet that looks like this. And on each page, there are descriptions of about 6 or 7 different clouds. What I want you to do is to get to an area where you can see some clouds. You might have to kind of walk over here. Oh, yeah, right here. There's some clouds over that way, clouds over this way. I want you to sketch what those clouds look like. And then as a group, I want you to see if you can figure out what kind of clouds they are and what that means about the weather. What kind of clouds are they? And what that might tell us about the weather.
Hey, bud. You want to show the camera each page? Because whoever's at home, they can like pause it. They can be like, oh, okay.
Here, I'll hold the map.
There you go. You want right around there. Just come where you can see some clouds. You might have to go around the building.
There we go.
This one.
Yes, sir, clouds.
Ooh, surfing. Oh, cool. Awesome. Yeah, you don't have to go. Again, they can pause. So they have to go super fast or super slow, but.
We have a page behind.
Stratus, nice.
Ooh, wait. We should look at these guys.
Ooh.
Cumulus. Like when you're flying an
Cumulonimbus.
airplane.
Oh, something bad's gonna happen there. Okay, thank you.
Yeah.